All right, today we're cracking the code on one of the most powerful financial ideas in the entire world. It's a force that can, believe it or not, quietly build a fortune from almost nothing. So let's dive right in.
I want you to just think about this for a second. What if the money you already have could start working for you? You know, earning its own income all by itself 24/7. It sounds kind of like a dream, right? But that's the fundamental idea we're digging into today.
So the official term for this magic is compound interest. Now, I know the definition can sound a little dry, but the concept itself is incredible. It basically means you earn interest not just on your starting money, but on the interest you've already earned. That's the key.
The best way to picture this is a snowball rolling down a hill. At first, it's tiny, right? It's barely picking up any snow, but as it rolls and gets bigger, it starts picking up more and more snow, and it starts moving faster and faster. That acceleration, that right there is the secret sauce of compounding.
And here's the really cool part. This incredible power isn't just random luck, not at all. It's predictable. It follows one single elegant rule, a kind of universal code for growth. And once you understand this code, you can start using it yourself.
And here it is. This is the master key. Let's just break it down real quick. A is the final amount you end up with. P is your principal, the money you start out with. R is the rate of growth, and N is just the number of time periods. It looks simple, but trust me, this little equation is behind everything from your savings account to how populations grow.
Okay, let's see this code in action, because it makes way more sense with a real example. Imagine you start with 18,000 rupees. After year one at 15%, you've earned some interest. But here's where it gets good. The next year, you earn 15% on the original 18,000 and on the interest from that first year. And the result? You're at nearly 24,000 rupees, just by letting the formula do its thing.
So using the code to look into the future is pretty cool, but its real power and what makes it so useful is that you can also use it to look backwards and solve all kinds of financial puzzles. So let's just flip the script for a second. Imagine you have a goal, a specific amount of money you want to end up with. How much do you need to start with today to get there? Well, guess what? The code can tell you that too.
You can really think of this formula like a puzzle where you can solve for any missing piece. If you know 3 of the variables, like where you started, where you ended, and the rate, you can always figure out the 4th. Let's see how that works.
Okay, just look at this example. Someone ended up with 3,630 rupees. They know it was invested for 2 years at a 10% rate. Well, by running the formula in reverse, we can figure out they must have started with exactly 3,000 rupees. The code literally reveals the past.
And it's not just for the starting amount. You can solve for time, too. Here, you start with 2,000, you end with 2,662, and you know the rate was 10%. So the big question is, how long did it take? The code tells us precisely 3 years. It's almost like a financial time machine.
Okay, you with me so far? Good, because things are about to get even more interesting. So far, we've been talking as if interest is just added once a year. But what if we change the rules? What happens if it's added more often?
Well, the formula adapts beautifully. If you compound half yearly, so twice a year, you just cut the interest rate in half, but then you double the number of compounding periods. Doing it quarterly, same idea. You divide the rate by 4 and multiply the periods by 4. The bottom line is simple. More frequent compounding means your snowball starts growing faster, sooner. Let's see what that actually looks like. Take 4,000 rupees at a 10% annual rate, but compounded twice a year. In just a year and a half, which is 3 of those half-year periods, it grows to over 4,600 rupees. The frequency, it really matters.
All right, now for the final, and maybe the most mind-blowing part of all this. We've been calling this a financial code, but honestly, that's only half the story. It's time to zoom way out and see what this formula really is. This formula, this code we've been using for rupees and interest rates, it's not just about money. It's actually a fundamental law of nature. It describes any system where the rate of change depends on how much you currently have.
And this right here, this is the big aha moment. Just look at these 2 formulas. On the left, we're calculating how a machine loses value over time, depreciation. On the right, we're calculating the growth of a town's population. Notice something. The structure, it's identical. It's the same universal code at work.
And once you see this pattern, you start seeing it everywhere. It can model industrial growth, the slow way inflation eats at your money's value, the price of a new car declining, or the explosion of a city's population. It's all the same logic. Here's a perfect real-world example of decay. This machine loses 20% of its value each year. Notice the only difference in the formula? That plus sign just becomes a minus sign. It's the growth code running in reverse, and it perfectly predicts the machine's value will drop to 128,000 rupees in just 3 years.
And now, back to growth but with people. A town with 216,000 residents is growing at a steady 20% a year. The code predicts that in just 2 years its population will swell to over 311,000. It's the same force, the same code, growing a city just like it grows a savings account.
You know, people often credit Albert Einstein with saying that compound interest is the most powerful force in the universe. Now, whether he actually said that or not is up for debate, but the sentiment behind it, it's undeniably true. This principle is a force of nature, quietly shaping our finances, our economies, and our world every single day.
So, this code for growth is no longer a secret. You can now see it at work, in your bank account, in the news headlines, in the world all around you. You understand the language of exponential change. So the only question